Assalamu alaikum wa rahmatullahi wa barakatuh. Good afternoon, everyone. Thank you for joining another session of MCBS Modern Chronicle series. My name is Salah Al-Hanshi, and I'm the Director of ESL and Academic Preparation at MCBS. I'm going to be the moderator of this session. Our college is a leading provider of higher education in Oman. MCBS has received local and international accreditations and other recognitions. At MCBS, we believe in quality education, and we welcome students, parents, and sponsors from around the world. So our topic for today is about deploying IoT against COVID-19 spreading. And the speaker is Dr. Nebojsa Bacanin. Before we start, let me explain how you can talk to us during the webinar. If you have any questions during the presentation, just write them in the question and answer area. We will have a question and answer session at the end of the presentation to answer your questions. So now we can begin. Our today's speaker is Dr. Nebojsa Bacanin. He has a Ph.D. from the Faculty of Mathematics from the domain of Computer Science at the University of Belgrade. He started university career in Serbia 13 years ago and was the Vice Dean of the Graduate School of Computer Science at Megatrend University. He currently works as an Associate Professor and Vice Dean at the Faculty of Informatics and Computing at Singidunum University. At Megatrend University, Dr. Nebojsa has actively been participating in establishing and accrediting a completely new faculty with bachelor, master, and Ph.D. programs in the computer science domain. At Singidunum University for the academic year 18-19, he was ranked as the best professor by students and the management in a competition that included 350 professors. Dr. Nebojsa has also published 2 books in the domains of cloud computing and advanced Java Spring programming. Dr. Nebojsa has extensive expertise in operating systems, computer networks, programming languages, databases, hardware, cloud computing, and many other. He is a holder of more than 30 industrial certificates from global IT vendors like Microsoft, CompTIA, HP, Oracle, LPI, and more. Now it's time to start the presentation, and I'm going to hand over the mic to Dr. Nebojsa to speak to us about how IoT can stop the spread of COVID-19. Just a reminder, if you have any questions, please post them in the QA section. Dr. Nebojsa?
Thank you, Mr. Salah. It's my great pleasure to be here today with you. And now we're going to discuss about one very interesting and important topic, especially these days. So thank you, Mr. Salah, once again for kind introduction. So I may start with presentation. Okay, let me share my screen. Okay, I hope that you all are able to see my screen. So, as Mr. Salah introduced me, my name is Nebojsa Bacanin, and I'm professor from the domain of computer science. My area of expertise is artificial intelligence, machine learning, as well as swarm intelligence algorithms. So today's topic is deploying IoT technology against COVID-19 spreading. Unfortunately, this is current and very important topic due to the fact that this disastrous coronavirus has spread all over the world. Today, we have to employ everything that we have at our disposal to fight against this deadly disease. Fortunately, with rapid development of computer science, many technologies then can be used against this very malicious epidemic have emerged. One such technology is the IoT, or Internet of Things technology, along with artificial intelligence methods and algorithms, particularly machine learning. So this webinar has primary and secondary objectives. So the primary objective of this webinar is to show how the Internet of Things technology can be efficiently used in preventing COVID-19 disease spreading. However, if we want to understand completely how this technology can be used with this objective, we must understand also some basics about this technology. So as secondary objectives of this webinar will be included the following: overview of Internet of Things technology and its applications, overview of technologies that enabled IoT, and those two technologies are viral sensor networks and cloud computing. And finally, as the third secondary objective, which is by my opinion very important these days, is the utilization of machine learning methods and algorithms in analyzing and processing the data captured by IoT devices. So this is one webinar that includes many domains, mostly computer science domain, and I'm from the domain of computer science, so I'm going to stick with this computer science and technological perspective of COVID-19 disease. The people who are not from the domain of computer science, I'm aware that there are many listeners from different domains here on this webinar. Those peoples will not understand so many technical terms, but I'm going to give my best to put this in the most simpler way. So the Internet of Things has been established as a medium for global connectivity among all sorts of devices, with more than 20.4 billion estimated connected devices worldwide by 2020. So what is basically Internet of Things? Let me put this in a simple way. So we have so-called smart devices that have some kind of chip on it. So they may do some processing. Also, these devices have so-called network interface cards that use them to connect to computer networks such as the internet. And also, these devices are able to exchange and communicate, to exchange the data over the high-speed computing networks such as the internet. So all devices that are able to capture various environmental data by using sensors, and that are able to transfer this data over internet, are considered to be smart devices. Let's take, for example, like smartwatches. Let's take, for example, like smartphones, smart televisions, smart refrigerators, and so on. So these are all Internet of Things devices. So if we put all these devices together, we may have something like smart home. Or more importantly, for example, if we take the city, which is full of these smart devices with many sensors that are tracking environmental data and so on, we have so-called smart cities. So this technology is essential to fight against this COVID-19 spreading, this disastrous pandemic, and we can use this technology to fight against this pandemic. So this is very important and hot topic today. So before I start detailed discussion related to Internet of Things, let's give some background of this COVID-19 outbreak. So as we all know, the recently discovered coronavirus, SARS-CoV-2, known by the name of COVID-19, is a novel respiratory virus that was initially detected in humans in December 2019 in Wuhan, China. Since then, this virus unfortunately has spread to more than 200 countries worldwide. And now we have more than 10 million of infected people with deaths of more than 500,000 at the end of June 2020. And these numbers are increasing rapidly every day. So this is very bad forecast, unfortunately. And since this is a novel virus, so scientists and epidemiologists still have to learn a lot about it. So we basically don't know anything about this virus. So the precise scale of this COVID-19 outbreak is not known at the moment, and it will take a lot of time, months, maybe years, to gather all relevant data and to derive the precise estimate of this spread. So this will include a massive testing of population in every country. So we'll see what is going to be next, but in the meantime, we have technological solutions that we can use as best as we can to fight against this disastrous and deadly disease. Here are some charts, and on these charts, we may see how the number of daily new cases as well as daily new deaths is increasing, you know, from this, I don't know, February 2020 till now. So the current global challenge of COVID-19 pandemic has surpassed the provincial radical conceptual, spiritual, social, as well as some other boundaries. So this is my very favorite citation that states that the COVID-19 outbreak may turn out to be technology's time to shine, because technology, especially skills and knowledge from computer science domain, can be successfully employed in combating COVID-19 disease. So now it's time to show the perspectives and the potential of all this outstanding technology to fight against this disease. And of course, one such technology is IoT, or Internet of Things. Let's explain this IoT once again, please. So IoT is nothing than a group of smart devices that have some kind of processor on it, and they have sensors. By using those sensors, these devices are able to capture various data from the environment, like temperature, blood pressure of the patients, and so on and so on. And then these devices communicate with each other, and then they transfer this captured data somewhere to the cloud on some servers, and on this service, this data is being stored. However, with this raw data, we cannot do much about with this raw data. We need sophisticated tools and algorithms to process this data. And for this purpose, we can use machine learning and artificial intelligence methods. You see, everything is connected. We have IoT, Internet of Things. Then we have this sophisticated machine learning and other artificial intelligence algorithms to process this data. At the end of this webinar, I'm going to show you a very simple machine learning algorithm that we can use to predict new coronavirus cases in Oman. So it's very interesting. And for you from the domain of computer science, I must tell you, machine learning is very, very important and very interesting domain. Okay, so let's see more about this Internet of Things technology. I think that this video will help us to better understand this technology. So let's please take 2 minutes to watch this video, please. I'm going to play this now. Thank you.
The Internet of Things, or IoT,
Okay, thank you so much, all of you, for watching this video. I hope that now the concept of IoT, Internet of Things, is more clear now. So let me show one IoT devices. Here I have a smart home robot named Vector. He has some motion detector sensors as well as some facial recognition camera. Here is the Vector. So this is a typical example of IoT devices. He's a very good smart robot and I use him every day. He's a very good companion, partner, and everything. So by using all these intelligent devices, we create a network in which we can exchange data in real time, so almost immediately, which is very important for stopping this COVID-19 disease. Sorry, in a moment, just to put Vector in place. Thank you. Okay, so in order to understand this IoT field more efficiently, we need technologies that lie below this IoT field. These two technologies are viral sensor networks and cloud computing. So I'm not going to engage deep discussion about this, but the viral sensor networks represent one of the most crucial components of IoT. So these networks are formed of small miniature devices which are called sensors. So we have sensors and they're part of each and every IoT device. And these sensors enable efficient communication between each other. And viral sensor networks, as some of you know from this domain, are used to monitor specific physical phenomena in a given environment. For example, they have usage in military industry, and as well as in some other industries. For example, these sensors can be deployed in forests to monitor if there is some kind of fire in the forest and so on. So these sensor networks are used to connect all these devices together, and it is essential to have these networks in order the IoT things to work. So here is example with this fire detection mechanism of viral sensor networks. So these sensors are transferring the data to the base station, which is then transferred to the internet. And on the internet, this data is stored on the cloud servers. And then when the data is stored on the cloud servers, this data will be then processed by these AI and machine learning algorithms. However, there is one problem with this sensor network. There is one big challenge. And that challenge is that these sensors typically do not have a high capacity battery. So one of the greatest challenges in this domain is to maximize the lifetime of the network. And for this purpose, for maximizing the lifetime of the network, efficient routing algorithm must be used. One routing algorithm is leech. However, this algorithm is deterministic, and this network lifetime maximization problem is NP hard problem. So in this case, we must use some kind of stochastic or meta-heuristic methods. So from you who are from the domain of computer science, this is very important and interesting issue, especially this field with meta-heuristics. And the other problem in viral sensor network domain is localization, because since limited battery capacity, some of the sensors have GPS devices, and most of the sensors do not have GPS devices. So we must localize unknown sensor nodes by using the locations of known sensor nodes. Here we have published many papers regarding this domain. Another field which is interesting here and important is cloud computing. We all know what is cloud computing. Cloud computing is basically when we are using resources that are not hosted locally on our local computers, but that are hosted on some other servers in the cloud. Why is this called cloud? Because we do not know the exact location of these servers. According to the NIST, National Institute of Standards and Technology, cloud computing technology enables on-demand access of a configurable pool of shareable resources via computer networks such as internet. And I'm going to skip all this because I do not want to put you many details in these areas. Only what I wanted to tell you that there are basically three delivery models of cloud computing: software as a service, platform as a service, and infrastructure as a service. So basically, every time when we are using some software or data that is not stored on our local computer, but that is stored on the cloud on some other server on the internet, we are using cloud computing services. And cloud computing is very important for this Internet of Things. Why is it important for Internet of Things? Because the cloud computing represents a platform for Internet of Things. So let's put this into simple words. So we use all these IoT, Internet of Things devices to capture all environmental data. And then this data must be stored somewhere. So this data is via this Internet of Things transferred to the cloud that provides infrastructure for storing this data. And again, this is performed by using computer network, more specifically this wireless sensor network that we were talking about. And then most important, on this cloud, we must process this data because when we gather raw data, it's useless data. We must process this data to derive some useful facts and useful knowledge. In other words, to extract information from this data. And for this purpose, we are using the machine learning algorithms as well as some other artificial intelligence algorithms. The same is with this COVID. If we want to control the COVID-19 disease, we must capture these various data by using IoT network. Then we must transfer this data to the cloud. This data is being transferred automatically by IoT devices. And then as the final step on the cloud, we employ machine learning and other AI algorithms to extract information from such data so we can generate reports in order that will show us how to avoid the spread of COVID-19 disease. So finally, when we get to know these major technologies like IoT, wireless sensor networks, and cloud computing, now we can show the IoT applications for fighting against this deadly COVID-19 disease. So in the next few slides, we are going briefly to discuss about these applications. So first that I should mention is that here we have some new term which is called the Internet of Medical Things. So when we talk about the IoT applications in medical industry, in the medical area, so we must know this term, the Internet of Medical Things, which is application of IoT for medical and health-related purposes, data collection and analysis for research and monitoring. So every time when we use device for medical purposes, we have Internet of Medical Things. So this Internet of Medical Things has been referenced as the smart care, as the technology of creating a digitalized healthcare system. So only with this technology, we may have an efficient infrastructure to fight against this disastrous COVID-19 disease. Also, there is one interesting fact that many companies, by using this Internet of Medical Things devices, have begun to implement something called smart beds. So these are smart beds embedded with chips. So these are like IoT beds, and these beds can, detect when the patient who's supposed to lay in a bed because he's infected wants to get up and to leave and so on. Okay, let's now try to watch another video about this Internet of Medical Things and how this Internet of Medical Things enables us to create so-called a personalized medical profile. Let's just watch this video for a moment. Okay, thank you for watching this video. I just got informed that you could not hear the sound of the video, so I apologize for this. I didn't know that you cannot get the sound, and I hope that you managed to conclude something for these videos. Thank you so much. So let's continue with this topic. So this is Internet of Medical Things, and this technology we can apply to fight this COVID-19 disease. Also, the IoT technology as innovative technology is very useful during the quarantines. So this innovative technology ensures that all infected persons due to virus are in quarantine because during the quarantine it's helpful to have a proper monitoring system. So all high-risk patients are tracked easily using by internet-based networks. So what does it mean? It means that when the patient is in quarantine, it may have various so-called wearable smart devices, and those wearable smart devices can track various data like blood pressure, ECG, EEG, glucose level, and so on. In this way, the doctor does not need to be with the patient because the patient is infected and the doctor may get disease from the patient. So the doctor in this way can monitor the patient's health from the remote location, which is a very, very important merit of this, IoT technology during the quarantine. Also, this technology can be used to track whether the persons are in quarantine or not. So to track whether the persons leave the quarantine or not. And also this technology can be very useful during the curfews. For example, in Russia, Moscow, the Russian administration have implemented many smart IoT cameras with facial recognition function. And these cameras can spot the patients with the accuracy of 95%. So during the curfew, if some person is on the streets where he or she is not supposed to be, the camera can spot this person, could recognize his or her face, and could issue the warning. However, when these persons are wearing masks, the accuracy drops to approximately 90%, which is still relatively good. So here is the figure that shows how these sensors can be used for remote patient monitoring. So again, here is a sensor network, and the patient has these various IoT sensors. So this data in raw format is being transferred over the network to the cloud center. Then this data is stored and analyzed, and based on this data, for example, the doctors are notified like the patient's got up, the patient is in bad condition, and so on. So the doctors, based on this data and these reports, may take some measures. Of course, there are drones. Drones also belongs to this IoT, family, and drones were used for many purposes during this Corona-19 crisis. For example, in China, the drones at the beginning of the crisis in December 2019 were used for delivering medical supplies. And also drones can be used for many other things, like at least there are four basic ways that drones may be used for inspection, broadcast, delivery of critical supplies, disinfecting common areas, temperature check, and detecting virus symptoms in the crowd. I personally like this feature because the drones have sensors that can measure the temperature of the patient, and with those sensors, by measuring the temperature from the distance, they can spot if someone in the crowd has a temperature, and then it could identify this person as a potential COVID-19 patient. Okay, so I read on this article that Oman also uses drones to urge people to stay home and to limit social gatherings. Also, I read that drone license is in Oman issued by Royal Omani Police. I read this, so I'm not sure about this. So please, if you have any suggestions about this, please post the question in the Q&A section. Thank you so much. So here's the execution of the plan against COVID-19 disease. So first, this is efficient execution plan against this disease by using IoT technology. First, we have health data monitoring in remote locations. So by using IoT technology, we can monitoring health of patients in remote locations. Then by using IoT technology, we could organize virtual management and meetings. So we organize meetings with the wider public because, you know, not so many people are aware of what the exact symptoms of COVID-19 are. However, if by using this technology, we organize like online sessions and meetings, we can inform people and then they can be prepared. Then we have the analysis of data received and controlling, and then finally we have the following up report attained. So when we gather data, we analyze data and derive information, and then finally we generate some reports about this, and we know how to behave, how to fight against COVID-19 disease, and so on. So let me skip this. Okay, now we have one important also term that we must know in order to understand how these IoT devices can be used against this COVID-19 disease. It's the cognitive Internet of Things. So let's put simply, cognitive Internet of Things is the use of cognitive computing technologies in combination with data generated by connected devices and the actions those devices can perform. So when we say cognition or cognitive function means thinking. And while computers are not yet capable of general human-like thoughts, they can now perform some of the same underlying functions that humans perceive as thinking. So these cognitive functions of computers involve three key elements. These are understanding, reasoning, and learning. Let's explain this further. So if we like to embed some kind of intelligence, some kind of thinking with quotes, you know, into these IoT devices, we have so-called the cognitive Internet of Things. So cognitive Internet of Things is a network of Internet of Things that is capable of thinking with quotes. So like smart technology. And how are we doing this? Again, we are doing this by using the machine learning and you know, other artificial intelligence methods and algorithms. So the fundamental idea behind this cognitive Internet of Things is to dynamically allocate radio channels for the exchange of information between the highly dense interconnected objects and to perform real-time communication and real-time analysis. So what does it mean? It would mean that, but we are far, the world is far from this, let me tell you. So it would mean that each and every person has some cognitive IoT device attached. And then, for example, if this person is walking on the street, this device will tell this person if there is some other person which is infected with COVID-19 disease. And if there is a person, then this person should, like, you know, like walk away and to take some preventing measures. So when we talk about this cognitive Internet of Things, we have a subset of this technology, which is the most current today, which is called the cognitive Internet of Medical Things. So it's the class of cognitive Internet of Things specific for the medical industry that plays important role in smart care. So when we apply these smart cognitive Internet of Things devices in the healthcare sector, in the healthcare industry, we have this cognitive Internet medical of things. And with these devices, we can exchange in real time various data like EEG, ECG, oxygen level, blood temperature, heart rate, glucose level, and everything. So we can instantly, in real time, track all these medical data and analyze data in the real time, which is very important. And also by using this cognitive Internet of Medical Things, we can analyze in real time social network, web, and so on, and we could extract in real time the number of new cases, like the number of deaths, and so on. We can do it in real time, which is, trust me, one of the most important things today, to have on time, in timely fashion, information and data which are analyzed and from which we deduce knowledge. So this is one of the most important applications of Internet of Things in fighting against COVID-19 disease. So this is a diagram that shows the place of cognitive Internet of Things. So first we have IoT, then as the subset we have a cognitive Internet of Things, and finally we have cognitive Internet of Medical Things as a subset of this. So now let's see how can we use this cognitive Internet of Medical Things. There are different applications which are very important, how we can use this outstanding, let's say, state-of-the-art technology. First, we could use this in real-time tracking. So by using this technology, we can in real time update the number of the cured patients of COVID, the number of the new deaths, and the new active cases in various locations. In this way, if you have such a real-time tracking mechanism, we are able to model the series of disease. We are able to build a mathematical model of this disease, and we are able to foresee how this disease is going to spread, how it is going to grow. On this example with machine learning, I'm going to show you exactly this. How we are able to predict new cases in Oman using machine learning. Then, of course, as I already mentioned, by using this technology, we could establish so-called remote monitoring of the patient. So again, by using these cognitive IoT devices, like smart cognitive wearable IT devices, also like smart robots, why not? Different kinds of devices. We could, in real time, gather all this, medical data about the patients, like pulse rate, temperature, breathing rate, ECG, EEG, and so on. And we could, in this way, remote monitor the patients. So here is an example again of this usage. Here we have a patient with all these IoT sensors and devices. And then this data is being sent in real time on the cloud. And then from the cloud, doctors access this data. And also based on the reports from this data, a real-time notification mechanism could be established. And in this way, the doctors do not have to be in close proximity to the patients. Then we have this application, this technology, which is rapid diagnostic. So rapid diagnostic is very important, especially for the travelers and immigrants, because, according to the policies of many states, when there is a traveler who enters the country, he or she must be in the quarantine for at least 14 days. By using this technology, we may be able to establish a rapid diagnostics of such patients, so they may be released in 2 days, for example. Then this is important also application, which is called contact tracing and clustering. So in this way, we can, trace the contacts of disease of the infected person. In this way, we could control the spreading of this disease. Also, by exchanging this data in the real time, we can generate so-called clusters. For example, we, divide the city in area like buffered orange, green, and red areas, for example. And in each area, we have a certain density of the patients. For example, in red area, we have like 100 infected person on 100,000, persons who live in this area, and so on and so on. So this is very important. And also for this clustering purpose, machine learning is being used, especially algorithm called K-means clustering, which belongs to the unsupervised learning algorithm. Of course, we could also apply this cognitive Internet of Medical Things for screening and surveillance, like with usage of drones and so on. And also we could apply this technology to quarantine monitoring, as I have already explained before, which is very useful application of this technology. Again, this is a diagram that depicts how we could use this technology for quarantine monitoring. And finally, one of the consequence of applications of this technology in this sector is reducing the workload of the medical industry. Okay, I give you example of Serbia. These days, we have so many new cases in Serbia. Really, it's terrible. And we even do not have enough hospitals where to put all those patients, unfortunately. And also we do not have enough medical staff. There are many medical staff who are infected, so they could not work, and also many staff took the sick leave. So if Serbia has this IoT, cognitive Internet of Medical Things technology, it will reduce the workload of medical industry. Unfortunately, we do not have this technology, and we're a big problem now. So this, like case study of my country shows how this technology could be very, very useful in these days. And also there is one application, private proximity registration. So if we have like smart wearable, we could have some kind of virtual geofence around us. So for example, if some infected person comes close to me and I have this geofence around me, my device will detect infected person in my close proximity and will warn me, so I will move a few steps back in order to, avoid to get infected. And again, prevention is very important. And this technology could be used for prevention purposes as well. So let me summarize this. What do we have here? Okay, in simple words, we have these IoT devices. These devices have sensors that can track various data about the COVID-19 patients, as well as of general, like ordinary people. These devices in real time, by using machine-to-machine communication, exchange this raw data. This data is then being transferred to the cloud on some servers on the internet, on the cloud. And then by using this raw data, we cannot do anything. However, fortunately, there are machine learning and AI algorithms that we can use to analyze this data. And by analyzing this data, we could extract useful information based on this data. And based on this information, we can take some actions. For example, by capturing various biometric data of patients, we could classify the data whether this patient is potential to be COVID positive or not. So this is a classical classification machine learning task. So by capturing features like blood pressure, temperature, glucose level, ECG, and so on, I'm not from the field of medicine, so I don't know all these parameters. But by capturing this, machine learning algorithm is able to analyze a large sets of data and to derive patterns from these large sets of data, and is able to classify the patient as the COVID-19 positive or not. So we could manually analyze data, but we could do it like for 1,000 patients in 1,000 years, literally. So that's why we use machine learning and computers to do this. So this is very important aspect, and I think like maybe in some other webinars, it would be very interesting to explore in more detail how these AI methods can be used in modeling and preventing this COVID-19 disease. Okay, I said that I'm dealing with AI. That's my specialty, especially these so-called nature-inspired algorithms like swarm intelligence, genetic algorithms, and genetic programming. Okay, and these are finally at the end, these are like a summary of critical merits of IoT for COVID-19 pandemic. So like benefits of using IoT in fighting against this disastrous disease. So first, the patient would get a superior treatment by using IoT devices. Then there are reduced chances of mistakes. There is a possibility for enhanced diagnosis. There is effective control as one merit, and finally, lesser expensive, especially in the medical staff domain. Okay, of course, there are many issues from this. There are many issues, when some device is capturing our data, private data, like when we are going, what we are doing, our biometric data, what we are, like blood pressure, temperature, and so on. There may be many, privacy issues with this data. We do not know where this data goes, who is using this data, who can use this data for some other purpose. We don't know this. So these are privacy issues, there are security issues, and of course, there are many ethical issues. But this is another question that I'm not going to discuss here in this webinar because I'm, looking at this COVID-19 pandemic as particularly from the computer science perspective. That's what I do, so I'm not competent to discuss about other aspects of COVID-19 disease. Okay, let me show you one example, okay, about how we are able to predict new cases in Oman by using machine learning. I'm not going to discuss about the sophisticated advanced machine learning algorithms like deep learning, convolutional neural networks, NFIS networks, and so on. I'm going to stick with simple models like exponential, logical regression, and so on. And as you may know, there are many programming languages that could be used for machine learning. And the most well-known and the most, let's say, user-friendly programming languages for this are Python and R programming languages. And now in this example, I'm going to use the Python to show you how we can model, how we could predict new cases in Oman by using machine learning. Okay, let me show you this. Now I'm going to share my screen, okay? I'm going to stop sharing this presentation. Let me share my whole screen with you, please. Okay, Jupyter Notebook. I hope that you're able to. Okay, just a second, please. Let me share screen. Okay, I hope that you're able to see my screen now. I hope, okay, so here is a so-called Jupyter Notebook. It's like a framework for developing Python code. And Python is very friendly programming language to artificial intelligence machine learning because it includes many modules of libraries that have many machine learning methods that are embedded, like pandas, scipy, Seaborn for visualization, scipy, or so on. I'm not going to, talk about all of this. So here we have a link for the public available CSV file with the new cases for all countries in the world. This list is being updated on the daily basis. So now I'm going just, to read this file. Here we have a data for the new cases and the total cases for all countries worldwide, including Oman, of course. Okay, I'm not going to go deep into the code. Okay, you see here that as this value for this data frame, I used Oman. That means that I want to read the data for Oman country, so only for Oman. So this is the head because these are the total cases and the new cases for the 21st January, 23rd January, and 26th January. So that's the time when this base was formed and when the new cases and total cases were, put into the base. So there are no cases in this date in Oman. But if I look at the tail of this, I can see that, for example, that now on the July 7th, so it's yesterday, it was yesterday, there were 1997 total cases with 1262 new cases in Oman. I think this database is relatively accurate because it consumes the data from the World Health Organization official database. But if I'm wrong about this, please correct me, okay? And I apologize in this case. Okay, so let's see, using visualization, how the total cases as well as the new cases are increasing in Oman over the period of time. You can see this exponential curve here, which is blue, that represents the total cases, and this red curve represents new cases. As you can see, there is a just slight increase in new cases, like in the previous month or so. Okay, I could also create some, histogram. And now, what's the catch here? Okay, so based on these curves, we would like to predict new cases. And I'm going to use a very simple machine learning function. So we would like to predict new cases. So look here. Now I'm manually creating some linear function curves, exponential function curves, and logistic function curves. I'm creating this manually, so I'm manually determining these coefficients for all these variables. So I'm doing this manually. And now, look here. So this black curve is the total number of new cases in Oman. This red one is linear, but with manually determined coefficients. This green one, as you can see, is exponential, and this blue one is logistic. And as you can see from this figure, the function that closely resembles the real situation in Oman is this green exponential curve. I hope that you agree. This exponential curve closely resembles this growth of total cases in Oman. And also, let's look at the new cases. For the new cases, I'm going to use Gaussian model. So these are the new cases, and this is the Gaussian model, and the Gaussian model closely resembles the new cases behavior in Oman. But this is something what I created manually. So not by using machine learning. This is something what I guessed, for example, and I know that it's not precise. However, let's now create all of this by using machine learning methods that will fit historical data for Oman into this model, and that will generate these curves for us. Let's do it. I'm simply executing the code, and here I'm going to use this logistic curve. Why? Because the logistic curve closely resembles this model. And now here some coefficients here. These coefficients have been determined by the machine learning algorithm, from which is this code, optimize curve fit function. And now I'm going to plot some of this data just to show you. Okay, look here, please. Here's the output. So these are the curves that were generated by machine learning optimizer algorithms. Look here, please. So this black curve you cannot see because it's below the green. This black curve represents a real total number of total cases in Oman. Above this black curve, there is a green curve that represents the curve that was generated by machine learning. You see how those two curves fit together. It means that it's a very accurate prediction. But we know data till this point, for example, for like 48 or something cases. But look here, this pink line represents prediction. So if in Oman situation, the number of new cases continues to rise at this level, at this pace. So for example, in August, there will be total number of like, I don't know, approximately 67 on 68,000 of total cases in Oman. I hope that this is not going to happen, and I hope that this is wrong, because in machine learning there's always something which is called irreducible error. This is something that's out of the scope, out of the hands of algorithms. So it's like something that it cannot predict. And here's the zoom of last 7 observations. As we can see, so this is a relatively, precise, accurate estimate of new cases in Oman. And this is parametric so-called curve fitting for this Gaussian model for these new cases in the case of Oman, of course. So I don't want to, overload you with this machine learning information and so on, but on this very simple example that I created for you, I just wanted to show you how we can use machine learning to predict new cases. So the real case scenario would be the following. So we would be using this cognitive Internet of Medical Things to capture real-time data about the new cases in Oman, for example. And then this data will be transferred to the cloud servers. And then on these cloud servers, which by the way represents state-of-the-art, ultra-fast servers, which are called hyper-converged infrastructures. So on these servers, we would perform this machine learning analysis, and we will be able, for example, to predict, a total number of new cases in Oman for like the next month, next year, and so on. But besides this very basic prediction, there are many other data analyses that can be performed with this data. So many data analysis, so machine learning and artificial intelligence is crucial in fighting COVID-19 disease. And those three technologies, IoT, cloud learning, cloud computing, and machine learning, place together in fighting this global pandemic. That would be all. Thank you very much for your attention. I know that I've been using some computer science terminology that some listeners who are not from this field are not familiar, but I hope that you understand the main points of this presentation. So if any one of you would like to cooperate in some kind of research, joint research, please do not hesitate to contact me. And thank you all again for coming here, for listening to this 1 hour webinar. And now I think we have some more time that is left for Q&A section. So thank you very much. So, Mr. Salah.
All right, so thank you very much, Dr. Nebojsa, for the insightful presentation. It was really interesting and relevant. So now we're going to open the floor for questions, and you can see that we already have some questions here. So if you have any questions, please post them in the QA section. And we're going to start with the first question. So there is this question about the role of human beings in the implementation of IoT and Internet of Things. What will be the role of humans in this implementation?
So you mean like the humans who create this technology, or just who implement this technology?
The ones who implement the technology, because now you have sensors, Internet of Things. This is going to replace human beings.
Yes, this is in some way going to replace the human beings, but not 100%, because there must be humans who will, monitor this technology, who will control, and who will program this technology. Human beings are entities that will program this technology and that will adjust technology according to needs, and that will control this technology. We cannot, avoid humans in this. Humans are the most important thing in this IoT ecosystem. Without humans, there will be no IT, there will be no fighting against COVID-19 disease with IoT technology. So humans are the most essential component in this. So the humans are here to, control this technology, to implement the new features of this technology, to, direct the behavior of this technology towards preset goals, what we want to accomplish with this technology.
Excellent. So this brings us to a second question from one of the participants. The question is there enough caliber to operate IoT and Internet of Things? Will there be more demand in the market for IT graduates?
Can you please repeat the question? I didn't get, because the connection was bittering. Can you please repeat? Thank
Sure.
you, Mr.
So this is going to bring us to another question about the skills and caliber needed for to operate the IoT and Internet of Things. Is there enough caliber to operate IoT and Internet of Things? And will there be more demand in the future, you think?
I think, yes, definitely there will be new demands, but let me say something, because these IT technologies are very user-friendly technology. And now, the person who is going to operate these things will have some kind of friendly user interface where everything's, like drag and drop, and everything is easy. Like we have nowadays in the cloud computing domain. We have a service that we manage through cloud computing, but everything is just to click. This person or people who are managing this IoT world will just have to click on certain features to enable the features and so on. So these people do not have to know do not have to have so sophisticated skills about this. And finally, there is always need for more people to operate these IoT things, the devices. And I think that the labor market will have a high demand for such people in the future, like from the whole computer science industry. So the whole computer science industry is a very prospective domain, and it will require many students in this domain of computer science. And the same is with this IoT domain, because there will be, in simple words, there will be a high demand for IoT technical geeks in the market, and also there will be a high demand for computer science students. So there is unquestioned, this is without a doubt. So it's very prospective domain. If anyone wants, to get into this career path, she or he should definitely choose this path.
Excellent. So there is another question. It looks like it's from probably a student. What skills should IT students learn now to prepare themselves for another probably disease in the future, or to fight COVID-19?
So the question is related to IT students. So
yes.
What IT? Okay. So first, let me tell my opinion. Okay, computer science again is very prospective domain, and there will be even higher demand for computer science experts in this domain. Students should learn so-called DevOps, development and operations. It's a new field, you may Google it, that merges infrastructure and developing, so programming. It's these are person between the developers and infrastructure managers, because in this new era of computer science, in the IoT era, these DevOps will be able to maintain the infrastructure and to program, to develop applications. And also, trust me, artificial intelligence is very prospective domain. I think that's the most prosperous domain currently on the domain of computer science. So there will be many job opportunities worldwide for machine learning, and it has only begun now. So in the next decade, you'll see it will be a boom of this, demand for experts from the domain of machine learning, IoT, and as well as from the big data technology. But this is a different topic. I'm not going to go deep with this.
Sure. Thank you, Doctor. So there is this question from Dr. Basant. It has been published in the QA question. If you would please have a look at it. Dr. Basant is asking about the assessment of emotional state. All right. So is it possible to integrate mental state assessment and emotions of COVID-19 patients for better cure? So the current diagnosis of COVID-19 is mainly dependent. The current diagnosis of COVID mainly dependent PI or pain.
Yes, of course, there is a whole branch of artificial intelligence that deals with it. This is called sentiment and emotion analysis. So by, capturing images of the patients and so on, we could, from the facial expressions of the patients, as well as from the pictures of other body parts of the patients, by using convolutional neural networks and deep learning, so that's basically image processing, we could make conclusions about the current patient state, sentiment as well as emotion state. This is what is done. There are many, intelligent machine and AI algorithms that are able to, to see how the patient and how the person in general are currently feeling, what they want, are they sad, are they happy, and so on. So this is very prospective domain of artificial intelligence, and I forgot to mention this is webinar because there wasn't enough time. So that's another application of cognitive Internet of Medical Things. This sentiment and emotions analysis. There are many smart algorithms for this. Personally, my team and me, we were working on some algorithms based on CNN, convolutional neural networks, and swarm intelligence. So we were doing the following. We were, like using convolutional neural networks to analyze various pictures from various persons for, emotion detections, and then we use swarm intelligence for so-called hyperparameter optimization. So we used hybrid artificial intelligence algorithms from this, and also want to emphasize with this. Recently, my team and I, that I'm working with, we have applied, we have sent a proposal for special issue in one state-of-the-art journal, which is in Q1 quartile. So it's like among the 5% of world state-of-the-art journals. So we have exactly this special issue. So artificial intelligence for sentiment and emotion analysis. So if you, would like to send a paper, please let me know. I will organize this. We could work together and so on. Okay, thank you. Sorry for, going too wide with this answer.
No, that's fine. That's fine. Probably one more question about privacy and security.
Okay.
Just in a nutshell, what's going to happen because people are concerned about security? These devices will be, sending data about people, personal data, I would say, about people into the cloud. So what measures are taken to secure the data of people and make them as private as possible?
Okay, regarding the privacy of medical data, it's up to some kind of, decision. It's on the policy rules of the system, let's say. So how the medical data is being handled, But let me tell you something about these privacy issues. So whenever we are giving our data to some third party like cloud service provider, we always, sign this so-called SLA, service level agreement, where this party guarantees that our data will be safe with them. But honestly, that's my opinion, we cannot trust these parties because we do not know what is going to be with our data. Maybe there is some malicious employee at this Amazon, for example, I don't know, cloud service provider, who is going to misuse our data as well as the data for other patients or persons and so on. So the privacy is a big and important issue and the question here, and also about the security. So about the security, this is not so big issue, because when we are sending the data that is captured by IoT devices to the cloud, we are using cryptography as well as some other, state-of-the-art secure algorithms like TLS, transport layer security, SSL secure socket layer. I'm sure that Dr. Ahmed Munir knows many things about this. So we're using cryptography with combination of secure protocols, and in this way we are protecting our data. But there is always this question of privacy. So when we give our data away to some third party, we simply could not know what is eventually going to happen with this data. So that's a big open question, big open question. and I do not exactly know what are the policies regarding the medical data. I think that it depends from country to country, and I don't know for the medical institution and so on. So this privacy issue, I'm afraid that it's a big question, and it's up to all of us as individuals to decide whether or not are we willing to share this data with some third party, you know. So it's up to us. But from the technological standpoint, from this security aspect, there are many security technologies which are state of the art, and they can protect our data. So that's not such a big issue. But this, you know, privacy, you know, when we give the data to the third party, this is issue. And so it depends.
Excellent. That was well explained. Another technical question here, very technical, I would say. I would pass this to you, Dr. Nebojsa. What is the impact of, so you can see the question, what's the impact of fog computing in the IoT field?
Okay, so the impact, so in simple words, without cloud computing, and also without edge computing as a subset of cloud computing, there will be no infrastructure for the IoT. So in simple words, cloud computing is simply technology that enables IoT. Without cloud computing and edge computing, IoT will not be feasible. You know why? Because these small smart devices do not have so much storing capabilities as well as processing capabilities. So the data is sent to the power server on the cloud for storage to be stored and processed. So without cloud, IoT ecosystem would not exist. That's like simple answer, I think.
Excellent. So one last question. It looks like this question is from an entrepreneur or probably a CEO, is asking about the cost of implementing IoT in the industry. Will that be costly?
It will be costly, especially in, like, you know, highly demanding industry to monitor, but not so much costly. Let's say I think that the benefits from this technology will in a relatively short period of time will overcome all expenditure and all investments in this technology. I'm not sure. It depends on the industry, in the area and so on. So it's relative question. It depends on the industry how exactly this is going to cost. But let me tell you, it definitely will be profitable to use this technology in the industry, and more industries are using this technology. So definitely this respected entrepreneur should consider using this technology in this field, in his industry or her industry. But
okay.
Simply it depends. I do not exact answer because there are so many variables. What kind of industry, what kind of equipment is there in the industry, what is the geographical location, and so on. So there are many variables. So I cannot give precise answer for this.
All right. So thank you very much, Dr. Nebojsa. I think we answered all the questions.
Thank you.
In our session for today. So the session was insightful. So thank you, Dr. Nebojsa, again.
Thank you.
So we're coming to an end here. We'd like to thank everyone for attending the webinar. There is an announcement for our new coming or the next series of the Chronicles. So if you see the screen, you can see the announcement is going to be on July 15th. I hope you can join us in another session of MCBS Modern Chronicle series. So with this, would like to thank Dr. Nebojsa for his insightful session, and thank you for attending the session again, and we'll see you in the future. Thank you.
Thank you so much, Mr. Salah, and thanks everyone for listening this, for using your time to be here. And I hope that you're going to love the computer science, and I hope that I give you at least some insights how we can combat this COVID-19 disease by using IoT technologies. Thank you so much, all of you.
Excellent. Thank you. Thank you, Dr. Nebojsa.